IIT Vadodara. He has a rich experience in research and teaching. Its research interests include security for federated learning, adversarial machine learning, scene perception, and path planning for autonomous vehicles, particularly in adverse weather conditions. He has published in reputed venues such as IEEE Transactions on Pattern Analysis and Machine Intelligence, CVPR, Pattern Recognition, IEEE Transactions on Intelligent and Transport Systems. His contributions have been recognized with Research Excellence Award from IIT Hyderabad. He has also served as reviewer for leading conferences and journals, including IEEE SNP, IEEE TIFFs, Neurocomputing, and IEEE Transactions on Neural Networks and Learning Systems. Today, Sir will be delivering a talk on AI-powered open-air off-street parking system for sustainable urban mobility, a real-world case study at IIT Hyderabad. We are truly honored to have you, sir. And now I hand over the session to you, sir.
Thank you. Thank you. Let me share my screen.
Sir, co-host.
I hope everyone can see my screen.
Yes, sir.
Yes, sir.
Yeah, is my audio clear?
Yes, sir.
Yes, sir.
Okay, great. Thank you. Okay. Mm, Yes, I think it's 8 p.m. in India. It's 6:30 p.m. here. So I hope everyone might be having a long day today at 8 p.m. So you might be hungry, or I hope you all had dinner. So so my talk shouldn't be boring or something. So I planned it in such a way to have it interactive along with the good learning experience. So first of all, to start with, thank you, ma'am. Thank you for such a great introduction. And I also thank for the invitation, especially AICT Training and Learning ATAL sponsored this online 6-day faculty development program on a very good topic, emerging trends in artificial intelligence for smart innovation and sustainable technology in especially Industry 4.0. That is a very interesting topic to start with, and which is organized by HK Societies, PDA, College of Engineering, Kalburgi, Department of CSC, and Department of EC. Thanks, one and all. So I'll be delivering the talk on Edge AI powered open air off street parking system for sustainable urban mobility, a real world case study at IIT Hyderabad, which is actually developed and deployed at IIT Hyderabad. So this talk is more going to be how do we tackle the real world challenges, not just developing something to a research paper or some good close environment. It's not like that. Taking our solution to a real world setting, what kind of challenges we will be facing, and because once we develop any solution, be it research based solution or product based solution, it should be deployed somewhere so that there will be an end user, right? So that is the main aim of this FDP, I hope, especially AI for smart innovation. And when you call about smart innovation and sustainable technology, especially in Industry 4.0. So that will be the tone of this talk, where I'll be discussing more about the real world challenges rather than something a model developed, data set tested, and this is the accuracy. It won't be like that. I'll be dealing more on the real world tone and challenges. I saw there are 175 participants, and it would be very hard, I know, to have this interaction, but try to be as interactive as possible, because through discussion will you learn more. And I also know the timing, it's 8 p.m. there, so you all might be having a tough day, but still try to answer my questions and be interactive. Raise your questions if possible, or write in the comments. I can read them. So we will be having an interactive session. So to start with, I would like to again ask one small question. If you can answer, I'll wait for some 10 to 20 seconds If I don't hear any response, I'll proceed further. So my question is, you might all might be driving and all might be going out, parking somewhere. What kind of parking you usually encounter? And have you seen any smart parking solutions in today's world? If yes, you can share your thoughts. We will set the tone from where you have whatever you have seen so far, and from take the talk from there. So, have you seen any or any smart parking solutions, and what kind of parking usually you do?
Sir, in India, I don't think any smart parking facilities, at least I have not seen. And it is the big headache for all the vehicle owners to park their vehicles in congested marketplaces.
Correct, correct. True, true, true. Any more thoughts? Anyone from anywhere? You might be traveling, so you might be also seen in other cities or anywhere, or if you have traveled abroad, if you have seen any smart parking solutions, anything, any thoughts? I will take one or two thoughts and set the tone for that, and I can proceed.
In smart parking, especially the vacant space and consume space is more important.
Yeah. So have you seen any such, solutions, smart parking solutions, where you come to know beforehand, whether there is any vacant parking or not?
Not such in India, but in other countries it is there. That
Yeah.
means some signals will shows.
Yeah.
Well,
Yes.
there are metros where we see airports where we see whether parking space is available or no.
Hmm.
And it also
Correct.
tells about the categorization of the vehicle's parking space, whether the space is available for a two-wheeler or a four-wheeler. We have seen, and token issuing we have seen
Yes. Yes.
parking space.
Correct.
These are some features that I have encountered and I have seen in India.
Great, great, ma'am. Great, great. So yeah, more or less, these are the answers I was expecting, and all of them are true because somewhere or the other you might be encountering token-based system. It may not be smart, but it still is a solution where, um, telling somewhere or a person standing in front of a parking, guiding you where to go and all. So such kind of solution. Also, keep in mind the tone of the talk would be, as I said, real world. It's just not only about the parking that we'll be talking, smart parking that we'll be talking about. What are the implications of it? Because as someone said, some a sir said, it's a real headache today. So if you don't find parking, it will be a headache, and the time it takes to find a parking, uh, park your car there, and the resources associated with that, maybe fuel or your time, and from the fuel there will be carbon emissions. So when I did this project in IIT Hyderabad, the main aim was to reduce the carbon emissions of due to this unnecessary search of the parking lot. So if a solution is developed, it not only helps us for the smart parking, it also solves the implications, real world implications associated with it. So I'll also discuss them. Uh, to start with, I'll first show the demo of the project, and then so you'll get some idea about what has been developed, and then the rest of the talk flows like that. So this is a 24-hour demo sampled at one frame per minute because I cannot play 24-hour video. So one frame is being projected as a output of this demo. So you can see from down bottom left the time here, which will be 1 minute. So it started around 10. So it will be next day, some around 7 a.m. in the morning. Okay. Now you also try to observe what are the issues that we face when we actually deploy a solution in a real world. And this is an open air parking. It's not a indoor parking or some different type of parking which we usually see. Since it's developed as a case study in IIT Hyderabad, we have open air parking available where there are no spaces, especially in malls. We have indoor parking or underground parking and so on. So this is a use case for open air parking. And as I said, it's a 24-hour video and you can observe the changes and the issues, which we'll discuss again as part of this talk. What can be the issues?
ಗೌರ್ಮೆಂಟ್ ಹೈಸ್ಕೂಲ್ದಾಗ ನಂಬಲ್ಲಿ ಇಲ್ಲೊಂದು
So now once the nighttime starts, evening time starts, you can see the lighting conditions get constant because it's a constant light, white light or a street light. And the issue now starts because when the light gets constant, you see on the top right or top, there are two cars and carefully observe them. That's not a AI error or some solution error, that's a human error. They are parked in between bays. And because of that, sometimes even if it is empty, it gets red, which means occupied. Yeah. So now that you have seen the demo, what do you think? Since this is a real world demo, it's deployed on a real world 24-hour time frame after developing the solution, after going through a good amount of problem solving process. This is a deployment. Now, what do you think after seeing this demo are the real world challenges that you observed from this demo? Yes, anyone can share their thoughts so that we can take it from there. Yes, not easy to find parking at daytime or peak hours. Uh, okay, I see. So a lot of
Optimization of space, sir, is it? The
um
parking space. The
Oh, no,
size
no,
of
man.
the vehicle with more
Okay.
parking, a small vehicle with large parking space parked.
Okay, okay. Yeah, yeah. That is one of the issue while developing solution. Just give me a minute. I'm just opening the comments. A lot of comments, so I just opened it now. So somebody said, "Can you please speak a bit louder?" So is it fine now? Is it fine now? Uh, Okay, great. So in Bangalore at Lulu Mall, somebody said available of park space as seen. Okay. Smart city project is implemented in India. Okay. Not easy to find parking. Okay. No, not utilization of entire place, object identification, accuracy. Yeah, yeah. These are the challenges. I'm talking about real world challenges because these are not expected as part of the process development. They are, they are like unexpected real world challenges. What can be? Yeah, segmentation at slot at night time is challenging. Depends on human parking. Yes, yes, yes. Else. Okay. Any other that you observe from this real world challenges? Light intensity cannot be controlled always. Correct, correct. Yes. The illumination variation because if you have seen uh, the shadow of the building from which there is a parking falls on the vehicles and it moves as the sun gets to dawn and things like that. To meet lighting conditions, correct, ml has to be strong to meet the lighting conditions, correct. uh, there won't be multi-level parking here because this is an open air parking, so there will be only one ground. That's a different type of parking. As I said, this is a case study at IIT Hyderabad. We have a open air, so we are not dealing with different types of parking, indoor parking, multi-level parking, underground parking. It's not about that. So, but like once we have an open air parking like this, what kind of real world challenges, deployable challenges that we encounter? That is correct. That is human error. People may not park in the, correct areas. That is always there. That is a challenge in the real world. Correct. Because of which there will be a difference in the count of the available versus occupied, empty versus occupied. Correct. Yes. Uh, Yes, weather conditions. This is a good weather so far. Yes, definitely weather conditions definitely will be a challenge, future challenge. That is one of the research area as well. I'll be discussing at the end. If the car size is very small, does it take into account? Yeah, I'll try to answer that at the end. Two cars in one rectangular area. Still, there that would be an issue. That would be an issue because this is like a bay. If you consider one bay, if two cars are parked in it, that's an human error. We cannot rely on any AI or any system. Okay, okay, okay. Great. That is like more or less the challenges that we encountered in real world. But if you try to sum up, these are actually the challenges which even today's AI will encounter. Mm, okay, okay, okay. Let me move further. Yeah. So you all got the tone of the talk now, which we will be discussing for the rest of this. And if you also observe, I mean, if you pay attention to this, the bottom left base are not visible because it's the camera that has some field of view. Once it is deployed, it can only occupy a part of the area, and others get either congested or not able to capture the entire parking bay. And tomorrow If you want to, increase the number of bays, you need to install one more camera or any wide angle camera per se, right? Boundaries. Yes, this boundaries also will be a concern because we cannot install multiple cameras and try to find this number of empty park and then try to, you know, interconnect all of them and give one number because at the end we need one number, right? How many empty parking bays are available? Imagine you are at the main gate of your college or your university, and this parking bay is located somewhere around 2 kilometers inside your, college or university. And at the main gate itself, you will be able to know how many empty parking bays are available at the parking lot one. Then you can decide whether or not to go there. If there are only five or six, by the time you reach there, there already might be filled. If there are some 20 to 30, then you can decide to go there or somewhere else. Suppose this information is not available, you'll go there first, search for the parking area, then you will roam around this base, and then, you know that involves a lot of time, effort, fuel, that leads to carbon emissions and so on. So our aim at IIT Hyderabad was to install displays at the main gate or at this circles or junctions where people can take turns accordingly to move to this parking bay or not. And this is a preliminary solution, and there's a lot to work on it. Again, there are a lot of research areas that can emerge out of it. Yes, maximum parking limited is 91. That is the space or parking bay limited. There are multiple such these things. So, but one solution can be deployed anywhere. That's the thing. But the main challenges are the real world challenges. Sorry, real world challenges which I was talking about, being it illumination variation or human errors or bad weather. And if you also observe, when the shadow falls on the gray cars, they get covered, and they also be treated as either occupied or empty. There will be a lot of false positives. If falls on an empty parking bay, the model thinks that there is a gray car, and it gives us empty. Sorry, occupied. So that's this. Those are the again few challenges. Correct. So we will try to pose this as research questions since all our faculty here, and if you are interested, you can further pursue research in these real world challenges. Okay. So now, if I have to ask you question, why AIML, that is clear to you, why AIML in this particular solution is required. First thing, and in general, why AIML you think is required sorry, there is a typo, for smart innovation and sustainable technologies. Where can you find, I mean, in this particular problem statement, why do you think AIML is required? If you think it is not required, you can also answer that. And if you and the other question is, in general, smart innovation and sustainable technologies for urban mobility, why AIML is required.
Think, sir, it is for data-driven decision making we need.
Mm-hmm. Correct. For this problem statement, what do you think, ma'am? Why do you think AI is required? Is AI is required
Because
first of all? That's a question. And if yes, why?
because the learning has to happen with this, and because it needs computer vision concepts. I don't know I'm correct or wrong, but may
Mm-hmm.
it needs computer vision, which is a subset of AI. um,
Mm-hmm.
Indirectly we say AI will be needed here for smart
Okay.
innovations or smart systems. And when
Okay.
it comes to sustainability, we are talking about 17 SDG goals, Sustainable
Mm-hmm.
Development Goals, maybe about smart mobility or energy optimization, like carbon footprint, what you spoke, sir.
Mm-hmm. Yes.
Yeah, and
Correct.
these are the things that I think. where we need, or climate modeling, because we said
Mm.
weather and climate also affects for this. One example is real-time deployment, what you're demonstrating.
Yes, yes,
This is
correct.
effect.
And yes, ma'am. Yes, those are correct. And ma'am said one interesting thing is real world deployment. I haven't gone there. I'll also touch that thing because when we say real world deployment, we cannot wait lot of time to for a system or a solution to give us the response, right? So we need instant because now what is the time? It is 8:30. Okay. 8:30, this is the parking occupancy with this much amount of empty and this much amount of occupied, but the model itself takes 10 minutes to process everything of a timestamp at 8:30 and gives you at 8:35. Okay, so at 8:35 you're getting a timestamp of solution of 8:30. So that is not desirable, right? So we need a real world solution and a real time solution. So real world has its own challenges. Real time also has its own challenges. That's where edge intelligence comes, edge solution comes, AI integrated with edge solution comes, and optimization comes because we want both accuracy and real time. Accuracy is we need as close as 100%. Like um, if there are uh, 10 empty, we need, if it's okay if it gives 9 empty or 8 empty, or it if it there are 100 empty, even if it gives 90 empty, it's fine. That level of accuracy we can maintain. But real time we cannot wait because once I take my car to park there, but what I see at the display monitor is a timestamp of the previous timestamp, then there is no point, right? So we it need to be real time. So these kind of challenges also be encountered while deploying a solution in a real world challenge. Okay, so any more answers you think, any more guesses? So AI can help build models that are more efficient based on ML, like training data sets. Also, AI, if integrated with computer vision, will reduce human dependency or error. Correct, right? So that's where AI is required in real world in general, right? It reduces human efforts. It improves accuracy, reduces latency, and that's where now we everyone are running towards AI, right? Okay. Um, any more responses which you think where why AI is required here and why AI is required in general smart innovation and sustainable technologies?
Maybe scalability, sir.
Correct, correct, correct. Yes. Scalability is also is also a concern, and AI will help with, yes, scalability, improving performance, improving real time, dealing with different weather conditions, because we cannot develop a new solution for each weather or each condition, right? We need to develop a solution that should at least live for 1 or 2 years. It should be generalizable. It should also be scalable. We cannot keep on developing more and more solution for new and new challenges, right? So yes, 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 that is where AI is required. Anyone, any else, anything else?
Fault
For optimal
tolerance.
resource,
Sorry.
Fault tolerance or reliability can we have, or
Mm-hmm. Fault tolerance in what sense, ma'am?
some critical operations or applications can we
Mm-hmm.
think, or some mechanism where it is a challenging task type of application, then
Okay, okay,
email
okay.
will help us.
Mm-hmm. Yes, that is okay. We will try. I'll try to come up to that point again. Fault tolerance and things. Someone else also spoke.
for optimal utilization of resources, or
Mm-hmm.
to cope up with the climatic conditions and bring in innovations.
Okay, you're talking very, very high level. Great. Those are correct answers. One thing you mentioned, which is optimal utility. Imagine that.
Hello.
Mute. Okay, great. So yeah, optimality is the concern here definitely, because let's say I have run this demo for 1 month. I've collected a lot of data, like 1 month. I'll get lot of data. Now I can do data analytics on this. Some base in that parking lot demo are not currently used, constantly not. So no one is parking there. Some analysis I've got, or uh, during these peak hours there are a lot of traffic and many of them are not getting used, or this much of them are doing this. So I can get a parking efficiency analysis. I can do data analytics based on which the base which are not occupied, there may be some issue, there may be some grass grown, or there may be some thorns, or there may be some maintenance issues. I'll come to know that also. So AI will help after developing this solution, after collecting enough data, after deployment, and after getting user feedback. User feedback is also a data that can be analyzed later, which can help in improving the overall layout. And one important thing which everyone industries are focusing now is user experience. So this is a solution. Think it's like a solution, deployed solution. We will collect user feedback and try to improve the user experience. So there also AI ML will help. So I'm picking points from whatever you said and amplifying it to for you to better understand the importance of AI ML here. Yes. And all these are research questions again. Anyone can pick up and start a research on top of it. Right. Anything else?
Sir, may I come in?
Yes, yes, please, sir.
So basically, AI will augment the thinking capabilities of a human being. It makes the humans more smarter. So that leads to smart innovation.
Okay. You are saying AI will augment humans?
No,
What if
the
you don't?
thinking capabilities, like for example, it will
Okay.
help think better in a correct direction.
Maybe it is an assistive technology that should be used as an
Yes.
assistive technology, sir.
Okay, okay. Yeah, I see what you are trying to convey. Yeah, that is an important point here. But when I am talking, AI is as an assistive technology is very good. Uh, but when I talk about sustainable and smart innovation, it will give us suggestions whether or not to take a decision. It's on us. Ultimately, we humans want to decide, but it will give us enough analysis, as I was talking about user experience. It will collect all the data and we cannot sit and analyze. There will be a lot of dependence data, and then we
Lot
have
of
to.
dependencies do we find here, sir, in when we are thinking of real time, like
Hmm.
data, as you were telling, sir, data dependency or framework dependency or hardware dependency for processing that huge amount of data in real time.
Yes, 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 that is true, that is true. So these kind of dependencies will lead to an optimization, and there is no 100% optimization. First you will release version 1, and you will get a feedback this is not optimized, or there are some loopholes in this solution. Then again, with the help of AI, as sir was mentioning, it will enhance our learning or give us more insights on where to focus, and then that will help us build even more smarter innovation or smarter solution than the previous version. That's how solutions are being developed in industries in versions using AI. And even if you think, 3 decades back where there was no AI, how usually people used to think and what kind of efficiency that used to come out from an individual human, now it has been enhanced to even 10x. So we are saving time, improving the performance, making it more real time, ultimately leading to better user experience. Correct. So that's the main aim of AI/ML. So all your answers are moving in that direction of you are thinking in the right direction. Let us try to understand this. I've developed a small exercise for even for the AI/ML background participants and non-AI/ML background participants to understand the importance of AI/ML on top of importance of artificial intelligence on top of human intelligence, because all we have is the human intelligence. And you might be asking a question: is there a necessity for artificial intelligence, especially in a smart innovation or the solution I developed? So for that we will do some small exercise. From that you will understand. Okay. um, okay, what you see on the screen now? What is this projected on the screen?
There's no
Yeah,
ostrich.
yes, an image of an ostrich. Correct? Everyone with me, right? Okay. Uh, what is this? Yes, what is this again?
Again, the same
Still,
thing, sir.
yes,
Ostrich in a
still
different,
ostrich.
same
Yes, yes.
ostrich in
Okay. We'll see whether they are related or blood related or something like that. Okay. Now, this is also an ostrich, right? Now, I projected only three images on the screen, and there are three different ostriches. Now, what kind of differences that you encounter, or what kind of differences that you see between these three ostriches? Visual differences. Like once you start glaring at it, you'll find once the differences, right? What are the differences?
The orientation, sir.
orientation.
Correct. Orientation, angle, size, views, different angle. Correct. I can see in many responses in the chat. Foreground and background. Correct.
Color feature of the ostrich a little blur or a little darker side on that.
Correct. 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 Yes, because all this will be because when your camera resolution is not good enough, you have taken a picture from a far distance, you will have blurry images, and if your resolution is not good, if you are defocused, and so on. Right. Background and information differ. Correct. Foreground and background, different angle, views, size, angle, background, position. Yeah, change in position. Okay, great. All these are correct answers. Let me continue. What do you see now?
Vulture,
It's an eagle. Okay.
eagle or vulture, yeah.
Okay. Yeah. What is this?
This is the same bird in a
Yeah.
different angle and a moving bird or something like
Okay. It's still
that.
eagle. Okay.
Still,
Great.
yeah.
Yeah. So what is this?
I think it's the same eagle, completely
Oh,
different
eagle in flight.
imitation.
No, no. I'm just asking the name of the bird.
Eagle,
In the chat, people have started giving it as caption. No,
eagle,
it's still eagle. Okay, great.
eagle, yeah.
My question is now, what are the differences? First question is, what are the differences between the eagle images? And what are the differences between the first three images and the next three images? Visual differences.
The position of the bird, I mean, transformations again.
Okay.
The wings, sir. The
Mm-hmm.
wings.
Correct, correct. Yeah, that's a good observation. The wings, right?
Things is transformation.
Yes. Mm-hmm. Landscape
And the
change.
landscape
Okay.
changes.
Yes,
Water.
background, basically. Background. Okay.
And
Yes.
the color
What
of
you
it,
identify in the down three images which are not present on the first three images? Okay,
Could you
eagles are
repeat the
flying, but
question, sir?
differs in position. What are the there is a concept called intra-class and interclass. So intra-class is within the class or within the category of eagle images that you see. What are the differences? That is the first question.
The first
And
set of images.
interclass. First set of images and second set of images. And second question is, what is the difference between interclass, top three images and bottom three images? Group together also you can say what are the differences.
There's first three images are on land, but here we see on different types of water, then
Hmm.
flying air.
Hmm. What you call that?
Which ones?
Uh, the nature of the birds, I mean, uh, the
Exactly.
capabilities of the birds.
Yeah,
Exactly, right? That's the first
yeah.
thing you need to notice. Like those are two
Yes.
different birds. One can fly, one cannot fly. There's a difference in biological structure, right? So, and one important thing is motion, action or motion. One is in under motion, which can fly, which can also sit on a top of a branch, I guess, and things like that. But other cannot fly because of its body weight and its biological structure. It cannot fly. These are the visual differences, right? There are images about neck down. Okay, okay, yeah. Once again, you can, if you talk about each of the biological structure, ostrich neck is long. Its claws are different. Its wings are different compared to the claws and the beak of the eagle, right? Yes, I see these comments correct. Eagle standing, landing on water and flying. Context is different. Up there are images about neck and down there are about wings. Yeah. Any other differences that you notice, especially in the picture quality or image quality? Texture, color, geometric features differs. Correct. Yes.
Sharpened
Transformation.
images. The images are very sharp when
Yes.
it comes to the below three images rather
Correct.
than
Correct.
the last one.
Perfect. Yes. Perfect. So you see different resolution. That's called resolution. Right? When you buy a camera or even if you buy a phone, first you check is how much resolution it has, back camera, front camera, right? So that differs. Features are more distinct if background is contrasting. Okay, I'm not talking about features. Okay, but it is clear and resolution. Okay, first one. Okay. Next three are kind of blurry because the photographer might be taking the photo from very far or its camera angle is not good. What if there is raining? Okay, it's raining, let's say, and you'll get water droplets on the image, and all those things are possible. Okay, so this is, since we are dealing with the parking project and then the demo and all, I've chosen this exercise for you to understand. Okay. Okay, let me move forward, because what we usually see as humans is this, and what computer sees all numbers, right, at the end, all zeros and ones, so all stacked together to form certain pattern, which we humans, we don't need to look into every aspect of it, but machine as a computer has to all the numbers, put it in some format, then only it will say it is as an eagle or a ostrich or a empty parking bay or a car or something. Okay. It's as simple as that. If How do you identify your children or your parents from the others in general? How do you identify?
Features, points.
Correct. Yes, facial features basically, right? Facial features and, yeah, pixels. Yes. Okay. So I haven't talked about the task. I just gave you some images, but the task here is, we have 10 million ostrich images and 1 billion eagle images together put into one folder in your desktop, let's say. And a task for a human here is he or she has to manually open each image from that parent folder and create two other folders, ostrich folder and eagle folder, and open each image and see whether it's an eagle or ostrich and put it in either of the folders, ostrich or eagle. Okay. For a single human, how much time do you think it takes to complete this task? Mhm. Yeah, for single
In
human,
general,
like a single person to do this task, you understood the task, right? There are 10 million and 1 billion. How much is 10 million? 10 million is 1 crore. 1 billion is 100 crores. 201 crore images are put in one folder, desktop folder, if you have enough storage. And then you have to create two folders manually, right click and create new folder, ostrich, new folder, eagle, and open each image and see whether it's a ostrich or an eagle and put it in either of the folders. How much time one person can do this task? In how much time?
I think it's a very exhaustive NP problem, sir. But if working 8 hours a day, if we do this, maybe we need 3 to 4 years.
No, that's a wrong answer. Anyone else who wants to guess how much time it takes for one person?
8 hours per day, maybe 10 years, sir.
No.
The
Anyone?
exhaustive task.
Yeah, only the person is only hired to do this task only. Okay, 8 hours or 10 hours, whatever time. Okay. Okay, let me break it up. Um, you how many images per day you can think you can open? Click it and open. Click it and open. 1,000, 2,000, 3,000. How many images?
It also depends on other factors, no, sir. How fast is our processor which opens,
You
then
have all the
that
good
various
processor in the
guidelines.
world. You have everything good. Forget about all those other things. But just if you click, you can open. So how many images you can open?
Even if it takes 1 minute per image,
No,
yeah,
not 1 minute. You cannot open in 1 minute, right? You just click it, you open it. The reason I'm saying all this is all connected to the real-time performance of whatever the solution I'm talking about. So in the next slides, you'll understand how difficult it is to develop a real-time solution, especially for the smart mobility and sustainable innovation. Okay. Okay. Let us assume a person opens 1,000 images. Okay, per day. He works 30 days per week, per month. So how many images per month? 30,000, right? A- and for 12 months, it's 3,60,000. So 1 year, the person can only open 3,60,000 images if we don't take any break all the days he are working. And 3,60,000 images, 10 years, 30 lakhs. Okay. And 100 years, it's still 3 crores. We have to reach 101 crore. So it takes a lifetime, or it a person, one human cannot solve it. Okay. So everyone agrees, right? So that is the issue here for the real time performance, along with the intensity or exhaustiveness, as you rightly mentioned, of the task. So here human intelligence fails. We cannot rely on a single human. Even if you hire multiple humans, it's an exhaustive process. They'll take years of time, and we don't have years of time to do this task. So here human intelligence fails, and we have to rely on some extra intelligence as an add-on to our human intelligence. So it's an hard problem, as you mentioned correctly, and it rule-based program fails. You cannot write a simple program to identify this thing We have to have some intelligent program to understand, because within these three images, top three image and bottom three images itself, you have found out lot of differences. Imagine there are 10 million images, a lot of differences. If you have taken a photo from very far and the image bird is very small, then it's highly unrecognizable for the humans, and we cannot expect a machine or a AI to identify it. The same issue happens in the parking as well, identifying that car which is parked in a shadow, and we have to identify it as occupied and give it as a tick, or it's occupied as we have to give it. So these kind of real world challenges exist, and where human intelligence fails, and hence we need an extra intelligence. Here I've given only two birds. In reality there are no two birds, there may be multiple birds. Again, that as we increase the number of birds, the complexity increases, right? So setting up the tone why AI is required here and how AI can solve some real world challenges. Moving forward to the solution, which is from here, I'll take over and I'll try to ask few questions. If you are unable to answer, it's fine. We can proceed. We have last 30 minutes left. Okay, great. So to start with the introduction, just a second, I'm getting comments. Hmm. So this open air off-street parking aims to identify the empty parking base on a real-time basis. That's the introduction I gave already. So its advantages: it eliminates the need for searching parking lots, lower individual environment footprint in terms of vehicular emissions, increases safety. Suppose the parking lot is already empty and you can book it, or you can register it, so that you can go and take your parking for yourself. So you can do that thing, so that it helps other parking users also not to enter into unnecessarily enter into parking bay, so it's already occupied or reserved for someone. And it reduces traffic congestion, improves the safety in also in terms of accidents, because the frustrated parking user may drive rashly, or take all those things might be happening. We never know what kind of behavioral things he or she might be going through. So, and on top of it, not getting a parking lot still irritates, and a lot of things happen. And reduce traffic congestion, especially in a congested parking lots outside, not institutional, outside, where people don't follow traffic rules and traffic congestion happen. And reduces stress due to, as I said, due to search of parking space. It is highly beneficial, this open air off street parking base, for educational institutions, shopping malls if they have open air enough space, restaurants, movie theaters, open ground events, like some procession or some um, rally is going on, or not rally, but some politician or some famous personality has come, and things like that. Many other places where parking lot is. So this open air solution, parking solution, helps in such scenarios. And yeah, this is what I was talking about. So there are a lot of types of parking. You might be seen of this on street parking, on the road itself. You might there will be parking spaces, off street parking, indoor parking, and indoor parking also, underground parking. There's multi-layer parking, and these different types of parking are available today. But this solution which is developed is off street parking, open air. Okay, and some uh, research has already been gone, and still people are doing a lot of research in this. So if you think earlier how to deal with problem statement like this, also on-street parking level of service based on this random undersampling decision trees were introduced. Their purpose was to data-driven parking level of service. Again, um, this is a service, like a service you can provide, parking as a service. Um, Just like we have hardware as a service, software as a service, we talk in the IT domain, right? Just like that, parking service is has become which is very much data driven these days. A lot of data collected: how much is parking MTD today, how many users have come, what different types of vehicles which have been seen. Some people also note down the number plates as well, and so on. And one important thing is, our solution only gives number of empty and number of occupied. To upgrade it as a research solution, we can also give a parking number or a bay number saying where exactly is the parking empty and where exactly it is occupied, and so on. Okay. So it exploits this particular paper exploits temporal information found in occupancy data to predict parking bases. But the issue with this here is requires manually calculated occupancy measurements as a ratio, and manual, always when you involve manual thing, it's again not an optimal solution, right? Second thing is IoT, which has already been there for so long. You install some IoT chips or something um, um, at each parking bay, and if an car gets parked on top of it, it gets a signal saying that there's a some vehicle has been parked. Accordingly, the number of parking bays have been get updated. So the issue with this, it is non-scalable. Someone is talking about scalability, right? So it's not scalable. If tomorrow, if I have to improve the number of tomorrow if I have to improve the number of increase the number of parking bays, again I have to install many more IoT sensors there, right? So but if I have to buy one more camera that is wide angle, and even if I increase the number of bays, the camera can capture the entire bay, that is still scalable. So AI solution, computer based solution, is also scalable and cost effective also, and maintenance will be low. So all this comes under developing a cost-effective solution, reliable, scalable, low maintenance, generalizable. So all this come when you are deploying a solution in a real-world scenario, right? So the proposed solution, whatever you have seen in the demo, is quite simple, but it's still there are real-world challenges into it. So we'll get some live camera feed video data because we have installed a camera. We'll get a video data, and during peak hours we will see a lot of difference in the empty and parking. But during evening hours or somewhere when parking is already get stagnated, all the vehicles have got parked, we don't see much difference. So we need to be again optimize and careful about what is the sampling rate that we take from the video. So video, let's say it's 25 frames per second. So for one frame, sorry, 1 second, you'll get 25 images or 25 frames to be processed. And if you process all the 25 frames, each frame will have its own time, and that will be multiplied with 25 times. So we don't need 25 frames to process. We have to pick one frame from that 25 frames, so that which is a representative of that entire second, and then process and give us the output. That improves the real-time performance. So overall, this has five main modules. We have to label the parking lot first of all, where exactly the parking bay area is present, and we have to crop them, and we have to do some perspective transformation because all the parking bays are not rectangle given the field of view, or the camera which is being captured, the images which the camera being captured. Sorry for that. Right. So next, data annotations. These are all part of AI development, AI model development. We need data. Once we have data, we need to annotate them, which are empty, which are parking. And here, annotations does not mean only we do daytime parking annotations and see how an image looks daytime. parking images, sorry, car images look data. Because we are dealing with a solution which is deployable, we have to deal with the data uniformly sampled at the 24-hour zone, like from the morning till evening, sunrise, sunset, nighttime, and some different lighting condition. Maybe some day it's cloudy, some day it's rainy. You have to collect those data as well. And then data collection is a major part here, right? So the first part is labeling parking lot. As I was talking about, this labeling will help in the future updating the solution, like next future versions of the solutions, where you can say not only how many empty and occupied, you can say which, where exactly is it empty and occupied. Again, with a single solution, you don't need to add one more sensor or one more camera for that. It's within the solution. Just write couple of lines of code for that. For that also, it helps this parking labeling. So we annotate a single frame because camera is fixed, it's not moving. Camera is fixed, so once we annotate, the parking place or base place remains same. So there are tools like label me which can be used for parking. Okay, once you label once you label and crop them to create the data, there are no perfect rectangles here, right? You'll get like this polygon shaped, and there's a lot of dark or not pixels which are not giving enough information. So now we need to, and if you train our model like this AI model, so whatever black comes, it will think it's a car, or but whatever enough black pixels come in the data, it thinks it's an empty bay. So we don't want that kind of noise. So if we crop the annotated polygon shaped bounding bows to generate a data bay, it results in uneven parking base with added black pixel noise. We have to remove that. So for removing that, we have added some simple logic. So just transformation, it's called perspective transformation, which goes by this. So the same image, which we will transform it exactly like an for a rectangular bay, and then the information is stored. Now, whatever the car looks like, it still is a car, and a bay, empty bay, still is an empty bay for the model to learn, right? So yes, now the important thing comes here, data set collection, which is again a part of research here, research involved here. It, as I said, at what sample rate you will sample the data, first of all, and what kind of, at what time of the day will you sample? Like during morning 8 to 10, when all the sorry, all the users come to park, your sampling rate should be more. Once the parking gets stagnated 10 to 12 maybe, or something like that, all the parkings have been filled, the sampling rate has to be reduced. So there is a dynamic sampling optimization involved in the data collection as well. When you collect or record the data from this installed CCTV or hike vision, some multi mini bullet camera, it's like a CCTV camera, which is cheap, and on top of it we will have our AI solution deployed on the edge that I will discuss further. So now it gives us some frame rate, and yeah, as a rate at which data is considered here is one frame out of 20 frames per 10 seconds to have that sampling. Here we have taken uniform sampling rate taken for I think 7 days or so, and so that we'll get enough diversity in the data. And also we have to make sure the data is balanced. Data should not be biased towards too many of cars class, or too many of empty base class. So if it is biased, or if you collect more occupancy data, your model will see or learn more from the occupancy. So the data should be balanced, unbiased, and then it should be sampled at a proper rate. Okay. Yeah, so data sampling resulted in the number of frames per minute as 6. Total number of frames, these many frames we usually get. Number of bays, there are 91 bays. So total number of bays will get 7,86,240. that is the amount of data that we have collected. Still, there's a possibility to collect more and more data, but we wanted it to test it in versions. As I was saying, we develop using this data. First we develop a model, we deploy, we'll get some accuracy, let's say 95% accuracy. 95% of the time we are able to correctly identify. Next we will add more data, understanding at what time of the day the model is not performing good. So we have to train that model more on that time of the data. Correct. So we will add more and more data on top of it. Then we will split the training data and test data like this to have some analysis. And this entire process of data collection, preparation, including camera installation, annotation. I think camera installed is also mentioned here. Huh. The camera is installed on a block where there is a parking on a seven-store building. It's a um, seven-store building at a height of 25 meters, on a wall, so it can cover the entire parking bay. Right. So entire thing took some 20, 30 hours with one human resource, which I was doing as part of this project. So 30 hours, entire work was taken, considered to for the data collection part. Okay. And we have proposed a simple lightweight CNN architecture or convolutional neural network architecture, which is an AI model for those who are not familiar with models and AI. So it's like a model or an AI program which, given an input as an image, it will tell whether it is occupied or empty after enough training. So that's what CNN model and architecture is. And the reason we have designed only 4-layer CNN is it's a two-class problem. It's a binary problem, whether it's occupied, a parking bay is occupied or empty. There's only two possibilities. Another thing is we need real-time performance. The heavy the model is, the more time it takes to process a single image. And if it takes more time, the same issue which I was discussing in the beginning, it will take more time to give us the output. By the time it gives us the output, the time frame or timestamp was already grown. Okay, so it takes 150 cross 150 image size and gives us a model, and we are able to get a test accuracy of 99.8%. And this four layered, why four layered is we have tried with 5-layer, 6-layer, on 3-layer also. This is the optimal model that we come up, along with identifying the real time performance which I was given down. So during deployment, we achieved a real time performance of 0.81 millisecond processing time, and per frame, that is total processing time has to be within that time frame of 1 second. Okay, to make it real time. So some other results, if you see, the daytime performance is like dropping 3 to 7% because of the different lighting conditions that you can see on the screen. Uh, Once the light falls on the building, it falls on the shadow, falls on the bay, and because of that, some bays, even if they are empty, because of that shadow, falling shadow, it feels like there is a gray car present and accuracy drops. So again, this is a real challenge, and there's this open research area to deal with this different lighting condition, especially when you're working with 91 bay parking lot. This is I think again, as I said, 99.8% on test data. um, yeah, nighttime we got very stable performance with a precision of 1, because lighting condition is constant, so model can able to recognize what is what. There is no change in the lighting condition, so it is better. But if you see, the occupancy is very less. Nighttime nobody parks, but at least this solution can be extended industry level, at a deployment level, at outside all those not education malls or other areas where there's a nighttime also, the lot of parking occupancy present. Okay. Yeah, nighttime performed better because of the stable lighting conditions. Overall, we got some good performance. These are the results, and we published this paper in a workshop. And I'll give you the reference as well. You can go through them later. Huh. This is again an important study. As I was talking, it's not only about giving an occupancy, empty or occupied accuracy. After collecting enough data, we can have a post hoc ablation study saying that at what time of the day there's a lot of occupancy, or bay wise. This is bay wise. Which bay is more getting occupied? And based on that, if some bays, for example, 31st bay is not getting occupied most of the time, there may be issue. It may be an issue from the AI side or camera capturing side, or it is actually a ground issue where the parking bay is not properly maintained. There's some thorns or some other issues, okay, which we can give it to the maintenance department. They can take care of that, okay. So all this can be done as a data analysis part post hoc when you deploy a solution in real time. Okay. Again, this is again a research area, how to improve the performance and how to make this graph constant, saying that all bays are constantly used by in a uniform way. Okay. So finally, coming to the individual hardware components that being used. So this Jetson Nano hardware module is an AI integrated module, which is like a very small device, but an AI integrated. You can run AI models on top of it, which is some 4 GB RAM. So if you deploy heavy models, it's an edge device. It cannot take up that much load, and it will take a lot of time, and real time performance drops. So you have to optimize the model along with deployment. We have used this Hikvision XR mini bullet camera. And if you have installed this Jetson Nano module at the camera itself, you can have a power source, but you can take this solution in a metal case with a power source or like power bank, and there should be enough fan to control its heatness and all, so temperature. So all these are individual components. So if you want to do knowledge transfer or sell this solution, or do some patent transfer or some knowledge transfer or technology transfer, still this hardware kit can be deployed or taken somewhere and tested solution at different parking bays within your location. Okay, so these are individual components that's being used as part of the solution. So there are a lot of research question, and also this individual, once you deploy the solution within this individual hardware, all the communication challenges, network challenges, latency, hardware challenges, power issues, everything. Again, those are also real world challenges, research challenges. Since I work in AI computer vision, we take these things as granted. They are good enough, but they are still research areas when you think about deploying this solution on a monitor, let's say. Now, from Jetson Nano to monitor, how do you manage the latency is low? There is no network uh, packets drop, or there is enough bandwidth and other things. Okay. So all these are research challenges, open research challenges. So to come up with a summary, to summarize, we have seen a case study on open air off-street vehicle parking management system using deep learning method. This work aims to understand the challenges in real-time computer vision-based parking solution, analyze both on nighttime, especially nighttime. Most of them don't analyze the solution on their nighttime data. Since it's a case study at IIT Hyderabad, we have both daytime and nighttime data. So we analyzed, as I said, 24-hour data, and our case study can help to relook at the parking services at IITH and parking systems in general, applicable to any open air off-street vehicle parking management system. And as I said, one limitation is the different lighting condition I haven't introduced due to the different weather condition. That again may lead to some drop in the accuracy. So how can we overcome that? Is again using some semi-supervised learning algorithms, and because we have enough data which is not annotated. So if we can annotate and use that data, that's again a research area, and developing some different level of algorithms is fine. Okay. So This is a reference of the paper Open Air Off-Street Vehicle Parking Management using deep learning, a case study, which is published in ComsNet Bangalore workshop in 2022. And this is my LinkedIn. If you want to connect, you can take a screenshot, and you can connect me later and ask any questions. Or I still have 10 minutes time. I'm open to questions. Thank you for your time and attention. So yeah, I am open to questions.
Any question from the participants?
Sir, I have one question.
Sure, please go ahead.
How can we integrate EV charging infrastructure with smart parking system to promote sustainability, sir?
Um, because both are two different things. If you are trying to ask me if AI is involved in EV charging, that's a different story altogether. But if you want to use sustainable vehicles in this, because if you see, we are also identifying the vehicle. So if we can identify the vehicle type, if it's highly carbonated, or it produces more carbon emissions, then later we can suggest saying that this much of parking occupancy we have, this much of carbon emissions coming out of it, so you can use EV vehicles in that case, and accordingly reduce the carbon emissions, which can be linked in that way. AI can give you that analysis post hoc, or post hoc ablation.
Okay, thank you, sir.
Yes.
And one more thing, sir. Can we
Mhm.
have something of blockchain enabled smart contracts for transparency in parking reservations?
Mm, yes. I think we can have them, but again, I'm not sure how scalable it would be and how real time it would be. Because when you talk about, as I said, when you talk about real world solution, it should be scalable, it should be reliable, low maintenance, and low cost. So blockchain maintenance, I'm not into blockchain, but here, if you see my solution, our solution, it's one camera installed and there is an AI model. So AI model has no cost. There will be only camera cost, and then the UAE, um, the Jetson Nano hardware cost, which we don't need to. You have to buy only once. There was little maintenance, and every time all you update is the AI solution. You don't disturb the hardware. Once it is set up, it's set up. So blockchain enabled contracts, I am not sure of that area, but again, if it's reliable and scalable, definitely that can be used.
Thank you, sir.
Thank you. It was quite clear. Thank you, sir. Thank you. Can you please display QR code? Sure, sure. Yes.
Any other questions?
So I'm reading charts. If you want to post any questions, given some time, you can post in the chat. I can answer.
If you have doubt, you can also contact sir later also.
Sir, one more thing, sir.
Yes.
Sir, this can we have something like dynamic pricing strategy in smart parking based on peak hours,
Yes, yes,
or any type of learning model can we have here?
Dynamic pricing, definitely. As I was saying, there's a parking number involved in here, right? So we can also test how much time the parking is being occupied. Accordingly, the pricing can be given directly to the. Actually, whatever I was discussing is part of our solution. Later, we want to develop it. So it's like every user is connected to a parking bay once he or she, once that number plate gets recognized and we get a parking allocated a parking accordingly the usage of the parking we can have dynamic pricing strategies. We can use AI to see how much we can manage the parking occupancy along with that dynamic pricing. So yeah, definitely. Yes, that is a add-on to this solution. Like future versions, you can add on to this solution. But all that is possible only first you have to improve the base performance of this occupied versus empty in real world conditions. Once you get in all conditions, bad weather, cloudy, rainy, you are getting 99%. Then you can rely on the data after you get of once you deploy this solution.
Okay, thank you.
Yes. Yes, yeah. Can we link simulations with AI technology? What do you mean by simulations? You can develop an interface altogether. Okay, an interface you can display at the monitor at the front of your gate, or you can use backend all the data and see that this much is a park. Actually, there are startups which have been developed to do this kind of things. They will provide you the entire solution. You don't need to work about for an organization. You don't need to think about anything else. All their website or the interface or the back end front end can take care of everything. Now AI can be integrated into it, which gives you the analysis, all the analysis I was talking about. I exactly don't remember. There's uh, thing you can write to me later. I can look it up and share you because I still have to. Yeah, you can also search for this. There are parking startups on this. If area and number of park occupancy increases, single camera will not suffice. Definitely, as I said, we can increase the angle of the camera, wide angle camera, and then that can there's 360-degree camera if you know that captures a 360-degree view. There the annotation changes. There won't be a polygon shaped parking. There will be rounded polygons or some different shaped parking base that also can be transformed into rectangle can be this we have thought of such solutions as well. Multiple cameras you can go through, but how do you correlate the because half of the parking bay is here, half of the parking bay is captured in one camera and half of this captured in another camera, or there is an overlap. Some bays are already captured in camera one and some bays are already again captured in camera two. How do you differentiate? Because at the end there are only 91. So you don't need to mix up this, right? So multi-camera, it's still a research area, but how do you correlate with the parking base to remove the redundancy and the duplicate parking base? Again, a research area. Yes. I think we are on time now, so you can rest of the questions you can ask me on LinkedIn or you can ping me there. Thank you. Thank you, everyone. You've been great audience.
Thank you, sir. So it was a very interesting talk, real world case study. And your talk kept us listening, and it is engaging because